So the way that you learn these is very similar to the binary case with the Perceptron algorithm. You start with weight 0, and then you loop through all the training examples one by one, and predict the current, make a prediction with the current weight vector that you have. So this prediction will be, as seen before, just the argmax over all of the labels of the dot products between that weight vector and the feature vector that you have. And then, instead of only updating one weight vector, since you have multiple weight vectors, what you're going to do is you're going to update the weight vectors that are involved in the error. So you're going to update the, well, first, if it's correct, there's no change, you don't do anything. But if it's incorrect, what you do is you lower the score of the wrong answer and you raise the score of the correct answer. So say that you have your feature vector f of x, and the correct label of this feature vector is actually y star. And in this case, with these weight vectors, it would be classified as y instead of y star. So what you would do is you first subtract f from the incorrect weight vector, which is, this is the update equation, and you add f to the correct weight vector. So the result will be that the correct weight vector will look a lot more like f, and the incorrect weight vector will look less like f. And you do this for all of your training examples. Any questions on this learning procedure? Okay, so let's step through a question.
Wait, so in the case where there are multiple wrong answers, do you just choose the one that's most wrong and update that, or?
Yes.
Okay.
So it's possible that you have another class, like y hat or something, and that weight vector is right here. And it's possible that, so if you have, and this is wy hat, that this, the activation of this new feature will be more than y star, but the current classification, given all of the weight vectors, will be here, and you only will update the incorrectly classified weight vector. Yes?
So you would classify the correct answer, you add the weight, but then all the other ones that are wrong, you just subtract the feature from all those weights, or just
You only subtract it from one.
the most one?
Yeah, so you predict with the current weights, and then only look at the wrong answer that you just got. And you subtract f from that wrong answer, from that wrong weight vector, and you increase, you add f to the correct weight vector. Okay, so let's step through an example. So say we have 3 different examples in our training data set. One is the words win the vote, one is the phrase win the election, and one is the phrase win the game. And say that we have 3 different class labels that we want to try and classify between sports, politics, and tech. So this, say the first example is politics, the second example is also politics, and then the third example is sports. Then what we'll do for each of these cases is we'll construct a feature vector. That's always the first step. So in each of these we have the feature vector is the bias, and then the presence of the words win, game, vote, and the. So for this first example, the feature vector would be 1 for the bias term, 1 for win, 0 for game, 1 for vote, and 1 for the. So this is this first example right here. And then your second weight vector will be 1 for the bias term, 1 for win, 0 for game, 0 for vote. Sometimes. Whoops. Guess it doesn't want to write. 0 for game, 0 for vote, and 1 for the. Alright, and then you do the same for your third example. And then you have each of these 3 weight vectors that you're starting with. In the beginning, they're all 0, except in this case, on the first one, we set the bias to 1. And then we first start with our first example, which is win the vote. And we have this one feature vector, and we dot product with all of the examples. And so the dot product with this first weight vector will be 1 times 1 times 1 plus 1 times 0, and so on and so forth. So W sports dotted with f of x will be the dot product of the 2 vectors, which will equal 1. And W politics dotted with f of x will be 0, and W tech dotted with f will also be 0. So in this case, the classifier will predict sports, which is incorrect. So what you'll do is you'll take your feature vector right here and subtract it from W sports and add it to W politics. So the new sports vector will now become 0, -1, 0, -1, -1, and the new politics vector will now become 1, 1, 0, 1, 1. And then we'll keep on. Then we'll look at win the election, and you'll take this feature vector, classify it. In this case, it will when you take the dot product of this vector with all of them, the highest activation will be for W politics, and so you don't do anything, and then you'll move on to win the game, and you'll keep on leaping through. In this case, the activation for win the game will not be highest for sports, so then you'll need to make an update on the incorrect activation, the incorrect weight vector, and the correct weight vector. So let's look at an example of this on a demo. So say we have this demo right here, and so in this case you have 3 different classes. One is blue, one is red, and one is green. And the blue arrow right here is the weight vector for the arrow. The red vector is the weight vector for the red points, and the green is the green. And then the yellow arrow is showing where the current example that we're looking at is. And so here's the code right here. So you can see it's very simple. You step through, compute the predicted label. If the predicted label is incorrect, which in this case it is, then it will update the red weight vector. It will add this point, it will add the yellow vector to the red weight vector, and it will subtract the blue, I think, subtract the yellow vector from the blue vector. So if we step through, then we can see that this yellow vector was subtracted from the blue vector, and then, whoops, accidentally finished the training. So we need to actually just reset. So we need to make this, there we go, okay. So we're starting off with some case, and we step through. This feature is incorrect, so we need to update the weight vectors, and we add and subtract. Then we look at a new example, which is the blue example, which is also incorrectly classified. And in this case, it's a blue point, so it will add this feature vector to the blue and subtract it from the red. So we can see that right here. Subtracting it from the red and adding it to the blue. And if we just continue this process, the weight vectors will be updated for all the incorrectly classified points, and the weight vectors won't be updated, it will stay the same if it reaches a point that's correctly classified. So over time, you'll be seeing the red points will be added to, the red points will essentially be added to this weight vector, the green points will be added to the green weight vector, and the blue points will be added to the blue weight vector. And you might say, why not just take the average of all the blue points and have that be the weight vector? That's something like what naive Bayes does, and it will do a pretty good job, but it won't take into account, it'll still have some errors essentially. And then once it has correctly classified all the data, so it looks like it's not quite done yet because we have these 3 green points right here that are in the red region, so they'll be classified by red. So once it reaches one of those points, and you can see that this process can take a long time because it's iterating through all the points, and if it goes through a bunch of points that has the correct classification, then it won't do anything, and it won't update. And then so here it's gonna make an update. And now it looks like it's done. It's because it looks like all of the points now it looks done. Well, actually no, so this point's still incorrect. But once it finishes and all the points are correctly classified, then it's done and it stops and no longer updates. Yes?
So when does the algorithm terminate? Does it look at every point exactly once, or does it keep on going until everything is correct?
It keeps on going until everything's correct, and then it'll terminate once it's gone through all of the training points and hasn't made a single update.
Okay. So is there any intuition as to why this algorithm is guaranteed to terminate? Couldn't it get into some loop where it keeps on updating in a cycle and never actually stops?
Yeah, so it turns out that it will terminate in the case in which it's separable, in which the data is separable, and actually that's what we'll talk about next. So